a very important thing that I want to share, but we'll not get into the proof of it. Not that the proof is difficult, but we'll not spend time on the proof right now, since it's sometimes used in problems on probability and other things. See, there is a sequence of numbers an, right? There is a sequence of numbers an, okay? And there is a rule for the sequence. There is a rule for the sequence. For example, if in the sequence I had an minus 1 equal to a constant, then this an would constitute an arithmetic progression. If I had the sequence like an by an minus 1, that's going to constitute a geometric progression, right? But if I had that sequence, recursive sequence as follows: an plus alpha an minus 1 plus beta an minus 2 equal to 0. Suppose this was my sequence. Suppose this was my sequence. What would I have you encountered a sequence of this kind? Fibonacci?
Yes.
Fibonacci?
Yes.
Right? An is an minus 1 plus an minus 2. But have you ever thought how an is solved for in Fibonacci? A0 is 1, A1 is 1, and then A2 is 2, and so on and so forth, right? And then, you know, there is an irrational kind of a number which is the solution to the Fibonacci sequence, right? After what I tell you, you'll be able to solve the Fibonacci sequence. Okay? So then alpha, beta are constants. And if I have a sequence an plus alpha an minus 1 plus beta an minus 2 equal to 0, how do I solve for an in terms of n? Solving for n means solving for an in terms of n. Again, what I'm going to tell you will be without a proof of the result, but if you have something like this, you constitute what is called a characteristic equation. Quadratic, which is like x squared plus alpha x plus beta equal to 0. Constitute this characteristic equation x squared plus alpha x plus beta equal to 0. If the roots of this equation are r1 and r2 are the roots of this equation, if r1 and r2 are the roots of this equation, then the solution to this is going to be of the form an is going to be some a r1 to power n plus b r2 to power n would be the form of the solution to this equation. Solution to this recursive equation would be an equal to a r1 to power n plus b r2 to power n. That would be the form of the solution to this equation, where r1 and r2 are the roots of this quadratic. A and b are determined based on, let's say, if you know what happens at a0, put n equal to 0, so you would know a plus b. And if you know a1 also, you have to know two members of the sequence. Say a1 you know, put n equal to 1, and then you know you'll be able to solve for an explicitly by obtaining these two constants a and b. That will be the form of the solution to this. So what was my Fibonacci sequence? Fibonacci was, do you remember? An is an minus 1 plus an minus 2, right? And I obviously want to solve for an, right? I want to be able to solve for an. And so this I can write as an minus an minus 1 minus an minus 2 as 0. So what's my alpha? Minus 1. What's my beta? Minus 1. Yes or no? My characteristic equation then would be CE. Characteristic equation then would be x squared minus x minus 1 equal to 0 would be my characteristic equation. The roots of this is going to be x equal to minus 1 plus minus root 5 by 2 would be the solution to this equation. Right? So it's like R1 is minus 1 plus root 5 by 2 and R2 would be minus 1 minus root 5 by 2, for example. Would be the form of the solution to this equation. You know what I'm saying? And then the sequence can be written as some A R1 to power n plus B R2 to power n, where R1 is this, R2 is this. And how do you obtain A and B? Say you know A1, you know A2. Right? From there you can solve for A and B, and you know you have a solution to the Fibonacci. You have a solution to the Fibonacci sequence. Yes or no? Right? There are times when R1 will become equal to R2. Roots are equal. Right? If R1 is R2, then let me tell you the solution to this equation, this recursion is going to be, say each is R, then the solution to the recursion is going to be A R to power n plus Bn R to power n would be the solution to this equation if the roots are equal. If the roots are equal, then A R to power n plus Bn R to power n would be the solution to the recursion. I want you to know this. Very soon you'll realize, when I solve my next problem of the sheet, you'll realize that this will come in handy. Some people try to solve this with a lot of algebraic manipulation, but right now I don't want you to get into that algebraic manipulation. I want you to know about this characteristic equation that you can constitute out of a recursion and then solve for roots. Then A R1 to power n, B R2 to power n would be An, the solution to this sequence always. Right?